be a fairly shallow dive into some of the tools that are available that I think a lot of people just don't realize exist if they're not looking at things. So just to introduce myself, I go by the name of Ming, which confuses a lot of people because I'm actually British, but my name is an old Scots name. And the bit that looks like Menzies isn't pronounced Menzies, it's pronounced Mingus. And as part of my attempt to try and teach the Sassenachs the correct pronunciation, it gets shortened down to Ming. And I then confuse people even more when I say that I live in France and they just get, "You're what?" So I've been a Linux and Unix consultant for over 30 years now. And I created Silicon Blade Consultants to try and come into the consultancy side of things. Playing around with embedded Linux for over 15 years, where I am doing consultancy, contracting and training on this. And I spend my days building Yocto systems for my various clients. So one of the questions that I will often have, we know that BitBake, especially that first BitBake, is going to take time. So what do we do? And I mean, we've got the standard XKCD. This seems like a really good thing. And for me personally, this is my personal sword collection. So I'm all with this, because I study historical European martial arts. I specialize in 15th century Italian longsword. Occasionally I get told my hobbies are a little bit niche. But so the other option you've got is look at your tools. One of the things I find when I am training and I'm giving out the actual course materials. So I've given out my course materials to my students, and in amongst all the lab exercises, I have this little directory called solutions. The number of students that fail to find it. I don't know if I need to put it in pink glowing letters, say, look here for a hint, but they just don't see it. So there are these tools within the Poky. There is Poky scripts, Poky scripts contrib. So as a show of hands, who has actually looked in the Poky scripts? That's quite impressive. I get a lot of people that just, I didn't even realize it existed. People look at the documentation and go, oh, I run BitBake. There we go, that's good enough. And then don't search anymore. So this is just going to be a shallow view into some of the things that we can be playing with. So I'm going to start off with the way I do things. A lot of this is going to be from personal usage. So my workflow is, I'm sitting at a Mac on my desk. I like that because I've got my big 3 screens and I can sit there, but I do my builds on a remote Linux server that is headless. Now, within the scarf gap, there is a setup VS Code little script that will give you all of these some nice little default environment settings for your VS Code. Within the OE init build env, there is a thing that will detect if you've got VS Code installed. Now, because I'm running a headless server, I don't have VS Code installed. Therefore, it doesn't pick it up. So this is just a nice little way of, I used to have my own VS Code settings and I'd have to copy it every time I'd create a new build, whereas this is now just doing the work for me and I can just run this. So it's just a nice little useful script. So this will do, it'll bring in some of your workspace for the BitBake, especially if you're making use of the VS Code BitBake extension. And then it's giving you on the things of save your resources by what you would actually need to exclude from your files and exclude from the iNotify so that you're not wasting your resources, especially with VS Code when it's trying to monitor all the things that are changing and your build directory is changing all the time. So it's just a nice little starter. Now, in terms of a lot of the things that I am doing for my customers is I'm trying to create a demo. So a customer will come to me and say, I've got a particular board and I want you to give me a demo that uses that board, and then start integrating some demo stuff. So I get this board and I now go, okay, I need to get this booting, I need to get this working. So I go and find what are the board support packages, what are the things available. And the number of times I've got some kind of repo or some kind of script that is just saying, and there we go, this is what the bit or the manufacturer says, as a demo, we can get you working on your board. And then you've got to try and work out how do you get your application into their demo, which I hate. The whole point for me is I want to build a project and then bring their stuff into my project, not take my stuff into whatever they think is the best way of doing it. So I'm needing to rip apart and understand what's going on. So I think most people would know BitBake layers. So we can just do a BitBake layers and it will now show me what all my layers are, where they are, and what my priorities are. So I've now got a handle on, so if I've just done a repo and I've done a build according to their instructions, I've got an idea now of at least what layers are going to be in the system and what I can therefore rip apart and bring over into my own system. But then again, quite often what you're wanting to know is the more detailed information. So under the Poky strips contrib, there is an image manifest. And the image manifest lists layers. And what that will now tell you is it's going to give you the URLs and the Git hashes of all of the layers that are actually within your system. So now we've got the ability of, so we've brought in this random repo that I've got to try and strip apart to work out how to rebuild it for my own project. Well, I've now got the information about where does it come from, what's the source rev, how do I now go about reproducing that for my own particular project. So this is what I would tend to use as my first step of ripping apart a repo and rebuilding it, in my opinion, correctly. My opinion might be wrong, but one of the next things I'm doing is, so I've followed the manufacturer's instructions and I've built their demo image. So what does it contain? So here under the Poky scripts, there is an OE package browser. And this is a nice little thing that is going to give you a graphical view of all of the packages that have been built for your system. And from there, you can now start exploring what is actually having been built, along with what are the options, what are the files, what are the licenses. So you now can get a lot of information about what has actually been brought into this particular system.
How does that work on a headless system?
It doesn't.
I have a patch for that.
Even better. Your options on a headless system are if you're running like an X server locally and you just do an export your display, which is how I get around it, or you just find a different way, put in put on a display onto that server so that you can have a look at it. Now we were looking at the previous thing on the BitBake getVar. Now I've seen a lot of people will use the BitBake getVar to just extract a particular environment variable. Whereas one of the things when I'm trying to debug things, it's not always what the value is, it's also how was it set. So by just doing the straightforward BitBake getVar on an environment, it's going to show you where it was actually set up within all of the particular recipes. So now you can start going, not only do I know the value of it, but I know how it was set. So if I'm trying to debug, I can then be going into those particular recipes and working out what has been changed, what needs to be played with, what needs to be overwritten. And then working with package information. So the OE package data util. So this is quite a useful little thing for a lot of things. So there are quite a few options with it. So if you were just doing a -h, it's going to show you the main options. But if I look at some of the main ones that I would be using. So if you're wanting to know what package installed a file. So you've got a file that you're wanting to modify on your image, but you're not totally sure which package it came from. So you don't know where you're going to be doing your BB append. So if you're doing the OE package data util find path, and then you give it the full path on the image, that will then tell you what package was used to actually install that particular file. So here I'm just doing a util find path on the userlib python 3.12 crypt.py. So I wanted to find out what installed that particular package. And then that would then come in, and it tells me that that comes from the Python 3 crypt, which I could have guessed anyway, but these were just, when I was creating the slides, I wanted some quick examples, and that was the first thing I thought of. But then got the opposite of, if you've got a package and you want to know what it will install, but you're not actually on the machine, this is going to tell you the information about the files it's going to install while you're on your build server. So you're not having to go and use a package manager to go and query it. We can just make use of the OE package data. So if you're doing it on the OE's package data list package files on a particular package, that will now tell you what files that package is going to install. So again, you've got it both ways. You've now got a chance of working out where things are and where things are coming from. Then you've also got, if you're wanting to find information about the package, we have the package info, and if you then give it a package, that will then tell you what your recipe is, what your version is, and also what the size of the package is, which can be quite useful, especially when you are trying to optimize your system. You can now get hold of the size of your packages. And then find the recipe that actually produced a package. So for the Python 3 crypt, there isn't actually the Python 3 crypt itself. If I do the lookup recipe, that tells me that it's coming from the Python 3. So I now, again, are getting more information about where things are so that I can do any modification to my system. And then dependencies. Now, I know I said that I was going to be saying that this is all about Yocto is more than BitBake, and I'm going to have a BitBake command. But that's because for all of the dependencies, we need to create our dot file. So using the BitBake -g, and then whatever your image is, that will then create your task depends dot. So this is now going to give the base package, or the base information that other tools can make use of to find out and again give you more information. So once you've got your task depends dot, we can then start doing things with it. So we want to know, how did that thing get installed? So what we've got is an OE depends dot, and then the -k key, so that is what is the thing that we're interested in. And then we've got a -w is saying where did it come from? And then we just need to give it the path to our dot file. So as an example of, I'm trying to work out, why did nettle get installed on my system? It's not something I asked for, but it's there. So if I do an OE depends dot -k nettle, -w, because I want to know why, and then give it the path to my dot file, it will then tell me that because it comes from the my production image, which asked for wget, wget asked for GNU TLS, GNU TLS asks for nettle. So now I've got this traceability through to go, okay, that is why that particular thing is on my system. I can let it be, or do I need to clean things up and get rid of things, again, if I'm trying to optimize my system. And then if you want to know the dependencies, so if you've got a particular package and you want to know what are the dependencies of this package, then we have the -d flag. So we've got our OE depends ... -k for the thing that we're looking for, the -d, and path through to our dot file. So for example, if I'm wanting to now find out what are the dependencies of nettle, so I do a -k nettle, -d, path through to my thing, and it will then now show me all of the dependencies. It depends on the automake native, it depends on binutils cross-arm, it depends on GCC cross-arm. So I've now got a list of all the dependencies. So again, I can be checking to see from a debug perspective, have I got things all sorted? From the build dependencies, so we've got our image manifest, and then we have the list depends. So that is going to show us what we're going to be needing to build a package. So if we're just wanting to BitBake an individual package, or if we're having issues with things, then we can just have a look at the list depends, and here I picked XZ. So now this is telling me that in order to build XZ, I need libgcc, I need libgcc initial, I need my Linux headers, the GCC runtime. So it's just a list of all of the things that I need to make sure are working in order to actually compile up that particular thing. Another interesting one that I found is the package config flags. So again, you've got all of these recipes, and you need, or sometimes you're interested in what are the options I've got with them, with the package config. Now you can either go in and have a look at each of the recipes, or you can just have a look at the list package config flags as a little script, and it will return all of the recipes with all of the options. So now you can see, oh right, those are the things that I can go and play with. These are the things that the recipe has already configured, or has an option that I can then put into my package config for that particular recipe. So again, it's just a nice little useful little time saver when you're exploring. And then the build history. So again, when I'm trying to optimize things, and I'm trying to look at what are the effects of the changes that I'm doing. So there is an option within your config to save a build history. If you're looking at the documents under the dev manual, have a look at the build quality.html. But all you need to do is, in your configuration, inherit the build history with a build history commit equals 1. What this will now do is, whenever you're running a build, is going to save a load of information that then can be used to start working out what are the effects of your changes. So we've got a build stats diff. So what this will now do is we can start feeding it what are the differences between a build. So here's, for example, I've gone back to my Python 3 crypt because that's what I was playing with again. And I've added that to my image. So if I now do a build stats diff -a, it's going to be showing me that these were the files that were added. So it's added in the libcrypt.py, it's added in, and I've just cut it because there was piles of information about all the things that have been changed in the image. So again, useful to be finding out what is changing between your builds. And again, optimizing of, especially when I'm trying to do my CI builds and I'm trying to reduce the amount of time spent doing that CI build so that I can get that validation faster. There is a build stats. Now this is actually enabled by default in the local.conf. So there is the user classes with a build stats. And what that will do is there will be a directory called build stats under your temp directory. And for every build, it will be putting in a whole series of build statistics, which is a good name for a build stats directory. There's some good documentation on the classes where it tells you about the build stats. But in order to actually make use of those, so what you will end up with in that build stats directory is a whole series of files that are corresponding to each of the tasks that are being, or that have been run for that build. So if you want to know, for example, how long each task took, so what are the things that we are needing to optimize? We've got a build stats summary, and then we just give it a path through to our build stats directory, and then that will start telling us how long each individual task took. Looking at the effects of changes, so if we've done something, we can see what is the time difference between two builds. So have whatever I've done affected the build time? In this particular instance, or whatever I was doing for these two builds, it's actually increased the build time. So in terms of an optimization, that was a really bad move. But at least I've now got the information about what my stats are. Checking patches. So I've got a system, I'm going to be looking at potentially handing it back over to my customer. I just want to do some sanity checking. There is a patch review. And what you do there is you will pass it through the path to a layer, and it will then go and have a look at all of the patches in that layer. So as my example here, I was doing a patch review on my little sample training BSP that I've been created. And it's telling me here that I've found 6 patches. It's got a missing signed off by on 3 of them. However, there are all of them, there's nothing that has a malformed signed off, there's nothing with a missing CVE, etc. So at least I know that my patches work. I just need to actually go and do my signed off by just to make sure that they are complete. But if there's any malformed things, it's going to flag them up so that you have a chance of fixing things before you ship. And it's always nicer to ship things cleanly than having to try and fix things afterwards. Writing to an SD card. So if you're not using BMap tool, which I think is what most people should be using, but there is a little tool that will handle just writing to the SD card for you. It's basically a nice wrapper around DD that works out what you've got on your system, but it just gives you a bit of information about your image that you're flashing and then the device that you're flashing to. So it's one of these things that is just a useful little thing if you're not using, or if you're trying to write your own, as I've had to use things like this where I've been integrating into a customer's legacy system and they want to use DD because that's what they want to use. So something like this just makes life better. So it's now your turn. What do you find useful? What are the things that are around that you think people should know about?
And it'll have to be quick.
I'm a big fan of the BitBake layers show overlay command, because when you get, someone has you a new layer to see what like BB appends or BB classes have been stuck in there.
Absolutely. Again, this is nothing when you're trying to analyze, especially when you've been given a repo, and say, what does this contain? So a thing like the show overlays is great.
Yeah.
Show appends, all these sort of things to find out so you can start delving into what's going on. Thank you.
That one in the back. And Joshua, do you want to come on up?
I also want to give a shout out to the OE depends .-y. If you're wondering why there's a binary on the system, you run -y in the package and it will tell you all the recipes that include it and provide that final binary.
Excellent. Thank you. So just a quick, but that's on my slides.